Hey everyone, this is 2.2 linear equations. This is basically just more advanced equation solving than what we saw in the last section. Technically, linear equation, they're talking about it being an equation that can be written in this form. Really, all it means is that your variable, the x, has to be a regular old x, right? It could be a y or something as well, but the point is you can't have like an x squared, you can't have a square root of x, you can't have an x in the denominator. It has to be a regular old x in the equation. That's what tells you it's linear. So for example, if I look at this equation down here, I know it's linear automatically because I have just a regular x and a regular x, right? That's what makes it linear. To solve linear equations, I'm going to give you 4 steps, which I recommend you throw on a note card you have in front of you at all times when you're solving equations, just so you remember. Um, Step 1, I'll let you read them obviously, but step 1 is about cleaning up each side of the equation separately. Before you start moving things to other sides, you want to make sure each side of the equation is already simplified as much as possible. Step 2 is about moving all of your x's on one side and all of your numbers on the other. And when I say x's, again, it could be like a z or a y, but x is pretty common. Get all your variables on one side, all your numbers on the other. I put add and subtract in parentheses because this is the step where you add things to both sides or subtract them from both sides. Step 3 is when you actually solve. You usually have just a number, basically one term with x on one side and a number on the other, and you get x by itself by either multiplying or dividing in that step. And step 4 is check your solution. You can always check to see if your answer is right by taking that answer, plugging it back in the equation, and getting an answer, basically, seeing if you get the same thing on both sides. Here's our first example. Now, one thing to note is from that checklist, you're not always going to start at step 1. Sometimes there's nothing to do for step 1. For example, here, there are no parentheses to clear, and there are no like terms on either side, right? We just have x's and numbers, so we can't combine those. X's and numbers, can't combine them. So we're actually going to start in step 2, which is where we want to have all of our x's on one side, all of our numbers on the other. So I'm going to start with my x's, doesn't really matter. And I need to get all of my x's onto one side. So I can either move the 3x to the right or the x to the left. I'm going to move the x to the left just because it's going to keep my x's positive, but it doesn't actually matter. So the whole point is I want to get rid of this x over here, and the way I get rid of a positive x, remember we're doing the opposite, I do a minus x. Right, because x minus x is 0, so that will go away. But it's a scale, remember, so I have to do the same thing to both sides. I have to do a minus x over there. Notice I wrote these underneath the pieces that they apply to, right? I'm not going to write the minus x under here because you can't combine those. Those aren't like terms. These are like terms. So what we're going to get is 3x minus x will give us a 2x. And the x minus x canceled out, so we just have a positive 6. Now all of my x's are on the left-hand side of the equation. All I have to do now is get all the numbers to the right-hand side, so that means this minus 2 needs to go over here. And the way I move it, the way I get rid of it over here, is I do the opposite, which will be a plus 2. And I have to do it to both sides. Minus 2 and plus 2 cancel out, so we have a 2x equals 6 plus 2 equals 8. So now that's the end of step 2. All of my x's are on the left, all of my numbers are on the right. The only thing I need to do now is actually solve, get x by itself. So now x is being multiplied by 2. I want to get rid of that 2, so I'm going to do the opposite. I'm going to divide by 2 on both sides. The 2's cancel, and I get x equals 4. That is our solution. We're claiming that the value of 4 is the value that when we plug it into the equation, we get a true statement. This is what that check looks like, right? Same equation. I'm taking the x, replacing it with 4, taking the x, replacing it with 4. This 3 times 4 is 12. 4 plus 6 is 10. 12 minus 2 is 10. See how it's a true statement? 10 equals 10. That means it works. That means 4 was the value for x that gave us a true statement. Here's another example. First, we're going to have to start with that step 1. Because we have parentheses, and we can use the distributive property to clear them. So this is going to be negative 2 times x, which is negative 2x. Then negative 2 times negative 4, which is plus 8. And the right-hand side, there's nothing to do, so we're just going to leave it. But that's what step 1 looks like, right? We cleared the parentheses. There weren't any like terms to combine, but still, we cleared the parentheses. Now we can start moving everything. In step 2, we want to get all of our x's on one side, so I'm going to do a plus 2x here to get rid of that. And I have to do the same thing to the other side, plus 2x. So now I have 8 equals 7x minus 6. So all my x's are on the right, so now I need to get rid of this minus 6. I'll do the opposite, plus 6 on both sides. And that should put all of my numbers to the left-hand side. So we have 14 equals 7x. That's the end of step 2. All my x's on the right, all my numbers on the left. We just have to get rid of the 7, so to actually solve, we're going to divide. Because remember, that's multiplication, so we're doing the opposite. 7's cancel, and we get x equals 2. Here's the check. When x is 2, when x is 2, 2 minus 4 is negative 2 there. 5 times 2 is 10. Then we have a negative 2 times negative 2, which is 4. 10 minus 6, which is also 4. There we go. We check that it works. Now when you solve an equation, there's actually 3 different outcomes. You can have one solution, you can technically have infinite solutions, and also no solutions. You don't know this until you get to a specific step, but basically this is what the step will look like. If you get to something like x equals a number, that means there's one number that works. That's one solution. If your x's cancel out as you're solving and you get something like negative 3 equals 3, or anything that's true, so you could have like 2 equals 2, 0 equals 0, something that's true that doesn't have x, that means that there's infinite solutions. That means any number would actually work to solve the equation. And similarly, if your x's go away but you get a false statement, something like 4 equals 0 or 2 equals 5, anything that's not true and doesn't have an x, that means there's no solutions. That means nothing would actually work to solve the equation. So when you're solving an equation, you don't necessarily know what's going to happen, but you're just going to go through with your steps and see what happens. In this case, we would distribute to get negative 6 plus 2x equals 2x minus 6. Now we want to get all our x's on one side, so I could do something like minus 2x and a minus 2x. But this is where you notice all your x's just went away. So what do you have left over? You just have a negative 6 equals negative 6. That's a true statement, so because that's true and because you have no more x's, this is your answer. Infinite solutions. And you have to write this part. You have to tell me about the solutions. You can't just stop at the negative 6 equals negative 6, because that doesn't actually tell me what solves the equation. Now you're telling me that, hey, actually any number, and you can try this maybe, take any number you want, and make sure you plug it into both x's, so maybe use 2 there, maybe use 10, maybe use negative 1, I don't care. Any number, when you plug it in for both those x's and you crunch the numbers, you should get a true statement. Right, same idea, we're going to solve this equation. This one has a bunch of stuff going on, so notice we're going to have to start by distributing twice on this left-hand side. So the first one is 4x plus 8 when we distribute. Then don't forget to send this negative through, so this next one is negative 4x minus 6. I'm going to point this out real quick. A lot of people forget when you have a negative number in front, this is, even though it's minus 2, treat this like a negative 2. It goes to this, it also goes to this one. A lot of people will treat that like a plus 6 and forget the negative goes to both. And then the right hand side, we didn't do anything. We're actually still in step 1 because we can combine some like terms. See how we have a 4x and a minus 4x? Those two will combine. And then the 8 and the minus 6, those will combine. And again, this is all step 1. We haven't moved anything to both sides yet, so we're just cleaning up each side. Now, 4x and 4x cancel each other out. Sorry, 4x and minus 4x. So all of our x's went away. And 8 minus 6 is 2, so we actually now have 2 equals 10. What does that mean? There's no x's left, and it's not a true statement, so in this case it's going to mean no solution. And again, you have to write this, you have to tell me about the solutions. And this is just claiming that no value for x would possibly work. You can pick any values, as many as you want, plug them both in for x, you'll never get it to equal 10. There's no way to solve it. Okay, so that's problem solving in a nutshell. This is probably the most, in my opinion, the most important section of algebra. It's kind of the heart of algebra. It's how do I take an equation, whittle it down, and get a solution out of it, and what types of solutions can I get. Let me know if you have any questions, and keep up the good work.